This is the second video for September 5th, September 6th. We're talking about the transformations applied to sine and cosine, shifting those functions left, right, up, and down. I might get cut off here by announcements, but that's all right. And so I went ahead and scaled the x-axis similar to what we did here because we're still dealing with a parent function. The period hasn't changed. So the period here is 2. In fact, we can actually write down the period down here. That's going to stay as 2 pi. We haven't done anything to change the period yet. Now, y scale, I wanted to pause because we do need to talk about that piece. Here, if we're adding 3, we're shifting the might be right. We're shifting the entire function up 3 units because we're adding outside of the function. So that's like dealing with this. So we're going to move up that many units. Well, if you think about the cosine parent function, its range was -1 and 1. Which means its highest value was 1, and we're shifting that up 3 units. So on our y scale, it might be good to go to 4, because if we were at 1, and we're going to shift it up 3, then we're going to have to go to 4. And just for symmetry, I'm going to make we're not going to go down 4 or 3, but I'm going to go down to -4 just for symmetry. Looks nice. Okay, so we have our x scale, we have our y scale. Now if we think about the parent function, here we were dealing with sine. So sine, quote unquote, starts at 0, 0, and then it has this shape. Here we're dealing with cosine. So because we're dealing with cosine, we're going to start at 0, 1. And then it has a similar pattern, a little different, but very similar. And so this would be our parent function. Again, I'm going to use a dotted line because that's our parent function. It's not our actual function. So we have our y scale, we have our x scale, and we have our parent function. Now we just need to perform the actual transformations. We already said that we're going to add 3 because we're adding outside of the function. We're subtracting inside of our function. Because we're subtracting inside of the function, that means that we're going to shift the function to the right, that many units. So in order to perform this transformation, what do? We notice pi, we're shifting to the right pi units. Well, if I look at my x scale, pi over 2 is here, pi is there, that's pi, which means pi is going to be 2 tick marks, if you think about it that way. Right, 1, 2, I'm at pi. So what we can do is move every single point that we have here, and we're going to shift it to the right pi, which is like 2 tick marks, and then up 3. So I take this point, I'm going to go to the right 2 tick marks, up 3, 1, 2, 3. This guy here, to the right 2 tick marks, 1, 2, up 3, 1, 2, 3. To the right 2, up 3, 1, 2, 3. To the right 2, up 3. And so now we have those points. It should be almost the exact same shape. It's going to be the exact same shape. All we've done is we've translated it to the right pi units and up 3. If you need to pause, rewind, ask me questions, please do so. We've already said the period is 2 pi. Let's stay on that train. Let's go with the amplitude. So when we did this I shouldn't have written that, but I did. Oh well. When we did this in class, a lot of students said the amplitude is 4 because they said from the x-axis to the top is 4. Well, notice here, in terms of the amplitude is the distance from the middle of the function to the top, or the middle of the function to the bottom. So we're not talking about from the x-axis, we're talking about from the middle. And here, we need to think about the middle in terms of our parent functions was the x-axis. Here, the middle was the x-axis because we didn't move it up or down. But here, we shifted the entire function up 3. And so because we shifted the entire function up 3, our new middle of the function is like here at 3. This is our new middle. And so what the amplitude is measuring is from the middle of the function to the top. That's this distance. That distance stayed 1. From the middle of the function to the bottom, that distance also stayed 1, which is why our amplitude is 1. If you have questions about that, please ask. All right, let's finish this up with domain and range. Domain is the x values. Again, it's still going forever in both directions. All we did was shift it to the right and up. So it still is moving forever in both directions. And our range, when you think about the range, we think about the lowest y value to the highest y value. We're not concerned about the parent function anymore. This is our actual function. So if I look at the actual function, the lowest value it's going to go to is here at 2. It touches at 2, so I can use a hard bracket. And the highest value it's going to go to is 4. So our range would be 2 to 4. If you have questions about that, please feel free to ask me. Those are the graphs of these two functions. You can also check your work using Desmos, which is really great. I'm going to show you the solutions for the next two. If you want to go through those at first, you might want to pause this video and then check your answers. But here are the graphs of those two functions with all of their key features. If you have questions, please ask me. If you want to pause, rewind, all that stuff might be great idea. But those would be those two solutions. I'm going to leave that there. I'm not going to show the solutions for the other ones, but if you want to try those and then ask me if those are correct, yeah, that works. I can do that if you would like. As always, if you have questions, please feel free to message me through mine, email, ask me in class, all those different resources. We'd love to answer your questions about if you're doing it right, if you have any misconceptions at all about what we did here.